Hello, geometry students. Welcome back to another lesson about circles. Flipgrid. Today's Flipgrid's up there. Go do it. It's good fun. Why not? You've already found the YouTube lesson if you are here. Now, pause the video and try these problems in your notes. Then unpause the video to do them with me. Okay. First, well, all of them. It says find the measure of the red arc or angle. Alright, let's take a look at number 1. Here's the red angle. There it is. It is a inscribed angle because the vertex is on the outside of the circle. And what do we know about inscribed angles from last time? Well, we know that inscribed angles are half of the arc that they subtend. So 90 divided by 2 is 45. So this angle is 45 degrees. Awesome. The end. Okay. Now, I am looking for the arc, but I have the angle. So now I'm going to do the opposite of what I did here, because the arc that inscribed angles subtend are twice the length of the inscribed angle. Or twice the measure, excuse me, of the inscribed angle. So, I need to do 38 times 2, which is 76 degrees. So the measure of this arc is 76 degrees. And I probably should have used a different color. That's okay. I will use a different color for this last one. Now, the red angle I'm looking for is right here. This one is a little bit trickier. So now I'm looking for this measure, and we know that it is half, whoops. We know that this is half of the arc it subtends. Now, is there a way, and let's do a different color there. So we don't know what this is, but we know that x is half of question mark. How could we find out what question mark is, though? Oh, I have this 72 right here. This 72 also goes with this arc. So if I do 72 times 2, that's 144. And then if I take half of 144, oh my goodness, that's just, go back to the red now, that's just 72 degrees. And that's actually a cool thing, that anytime two angles, whenever an arc subtends two different angles, those angles actually have to be the same measure. Fun fact. Okay, so those are our entry task problems. Now, let's see what we're getting into today. Today, we are jumping into section 10.7. We are skipping section 10.5 and 10.6 because we don't have time, and this is more important. More important, relatively. Yes. So, today is about the equation of circles, and you're going to be able to write and graph equations of circles. So equation is the key word here. We're still working with circles. All of chapter 10 is about circles, but now we're focusing on the equation of circles. Speaking of the equation of a circle, here it is. So please make sure to write this down. This right here is the equation, the standard equation of a circle, with center HK and radius R. And where this formula comes from can be seen right over here in this picture. If you want to write that down, go for it. I'm not requiring you to draw the picture in your notes, but it gives you a good idea of where, like the h minus k and the y minus k, it gives you a good idea of where this formula comes from. So make sure that you have that in your notes. Pause the video if you need to, and now we're going to move on. Here's a fun fact, not required for your homework, so you could skip this portion of the video if you wanted to. The standard equation of a circle can be derived using the Pythagorean theorem. Oh my goodness, we learned about that last chapter. So, remember a squared plus b squared equals c squared, but now we have x squared plus y squared equals r squared. Because any point, well here, let me make it clear. Any point on the outside of this circle is gonna create a right triangle like this. If I put a point right here, and I dropped that perpendicular line, now I have a right triangle here. If I put the point right here, now I have a right triangle here. So no matter where I put the point on the outside of my circle, I can still create a right triangle like that. And we just call, because this is the x-coordinate, right, on our axes. X-axis is side to side, y-axis is up and down. And then the radius of our circle, of course, is from the center to the outside of the circle. So that is actually where the standard equation, this one, that's actually where it comes from, is the good old Pythagorean theorem. Alright, so that's a fun fact. Okay, this is required, so make sure that you watch this. Example 1, writing the standard equation of a circle. So what I recommend when you do these problems is you just write this down on your homework. Write it down nice and big at the top of your homework. Put some hearts and stars around it, because it is important. X minus h squared plus y minus k squared equals r squared. With some little hearts and stars around, because this is the most important thing. Every example we do is going to use this, and I'm going to write this down at the top of every example we do. So, main takeaway is this formula right here. Write the standard equation of each circle. Well, you'll notice that up here it talked about the center and the radius. So anytime we do a problem like this, we are going to need to know, we are going to need to know what the center is and what the radius is. So, for A, we're doing the circle shown at the left. The center is here. How do I know that? Well, I know that because this point right here is 1, 2, 3 away, and this point is also 1, 2, 3 away. 1, 2, 3, 1, 2, 3. So this point, I can tell, is the central location of the circle. Every point on the outside of the circle is 3 units away. So I know that this has to be the center. This point right here is 0, 0. We also call it the origin. Same thing, 0, 0, origin. So that's our center, beautiful, and our radius. Hey, we just talked about what the radius is. 1, 2, 3, 2, 3. The radius is 3. So now what we're going to do is we're going to take our handy-dandy formula right here, the standard equation of the circle, and we're just going to plug in this information. So x minus 0 squared plus y minus 0 squared equals 3 squared. Now, you can simplify this, because what is x minus 0? Well, it's just x. X squared is x squared. Y minus 0 is just y. So we have y squared, and 3 squared, 9. And there you have it. That is part A. Let's do part B, and let's do it in a different color because we can. A circle with center 0, -9, and radius 4.2. Hey, isn't that nice? They gave us the center and the radius. They did all the heavy lifting for us. So now all I have to do is I have to take this information and shove it in there. X minus 0, remember, because this is x and this is y. So x minus 0 squared plus y minus -9 squared equals radius 4.2 squared. Okay, now let's clean this up a little bit. Remember x minus 0, that's just x squared. And, oh, what happens when I have two negatives next to each other? I have minus a negative. What happens then? Remember, when I have minus a negative, they come together and become positive. Come together and become happy. So this is actually y plus 9 squared. And 4.2 squared is 17.64. So there is your final answer. Ta-da! Okay. Wonderful. That's example 1. Let's make sure that we were right. Booyah. X squared plus y squared equals 9. Got it. Y plus 9 and 17.64. Cool. Got it right. Okay. Next, we are going to write the equation of a circle again, but this time there's a catch. So, remember, I'm going to write down x minus h squared plus y minus k squared equals r squared. Wonderful. Remember, this is the key. This is the key to everything we're doing today. Most important thing. So now we have the point, do a different color, 0.5, negative 5, 6 is on a circle with the center negative 1, 3. Write the standard equation of a circle. Okay, remember the two things I need to write the equation of the circle. I need the center and I need the radius. Well, I'm given the center. The center is negative 1, 3. Cool. But the radius is... The radius is... Well, let's see. I could... Ooh. If I zoom in on this picture, I could just drop this line straight down and count these boxes. But how do I know for certain... How do I know for certain that this edge of the circle is perfectly... How do I know that it perfectly crosses right here? You know what I mean? So, you could take a chance and you could count 1, 2, 3, 4, 5. It's probably safe to assume that it's 5. And if they give you a graph, you could assume. I want to double check though. I want to double check. Because these are the points they gave me in the problem, so these are the points I should probably use for the problem. So, this is my radius. Remember, this is also a radius, but these are the points that they gave me, so these are the ones that I'm going to work with. So how could I find the distance between these 2 points? Distance between 2 points? Maybe I'll use the distance formula. Oh my goodness, we learned about that back in chapter 1. Anybody remember? There was something about a square root in there. There was like the square root of x1 minus, or x minus x1 plus like y1 minus, y2 minus y1, and all of that squared. Wow. Wow. Yes, indeed. And remember, this is just the Pythagorean theorem in disguise, so that's how I remember it. But wow, okay. So let's do that, and remember this is x1, y1, x2, y2. So this is negative 1 minus negative 5 plus 3 minus 6 square root squared. Okay, so now negative 1, remember these come together and become happy. So we have 4, squared. Oh goodness. Oh goodness, what are we doing? That square is not on the outside. Oh my goodness. The squares are on the inside, and then we take the square root of all of it. Goodness gracious. Okay, 4 squared plus -3 squared, and then we take the square root. Whew, we've been cooped up inside too long. It's hard to remember these things. Okay. And now 4 squared is 16. -3 squared is 9. And we get square root of 25. Oh my goodness. Which is indeed 5. Perfect. So, we were right to just count down when we counted the boxes and they were 5. We were totally right, and we could have done that. Alright, radius is 5, center is -1. Awesome. So now we have enough information to fill in the blanks here. And I can take x minus -1, but remember that's just going to come together and become happy, so let's write that from the get-go. X plus 1 squared plus y minus 3 squared equals 5 squared. And 5 squared is, you guessed it. Well, not guessed, you know it. Is 25. Ta-da! There you go. Oh my goodness, that is hard to see. Let's write that. 25. Perfect. Oh, there you go. Now you can see it. X plus 1 squared plus y minus 3 squared equals 25. Wonderful. Excuse me. We have one more example, and then an optional example for some bonus. Okay, beautiful, beautiful. Yep, got it. So, the last required example. Now, it gives me the equation of the circle. See that? It gives it to me. I'm supposed to find the center and the radius and then graph it. Okay, so center. The center is, well, remember that's just these pieces. So, oh, but a little bit different because remember, and yeah, I'm gonna write it again, x minus h squared plus y minus k squared equals r squared. So remember that in the formula, these are minus. So when I have -3 right here, this is actually just a +3. And when I have +2 here, that's actually a -2. Because this negative right here, when I plug +2 in there, it would be x minus 2. But only if I put -2 in there does it become positive. So when you're going from the equation to finding the center and radius, you have to make sure that if it's positive, you take the negative, and if it's negative, you actually take a positive. Okay, and the radius, well, remember, different color, this is r squared. So r squared equals 25, which means that r is 5. So the radius is 5, and the center is -2, 3. Wonderful. So we did this part. We found the center and the radius. Now we need to graph. So let's come over here. Since this paper's already green, it's already black. Let's do green on top of it so it's easier to see. X, Y. And now let's make our circle purple, because I like purple. Okay, center. We're going to start at the center. -2, +3. So there's my center. Perfect. And now my radius is 5. So here's what I do when I'm graphing, because what does 5 look like that way? I have no idea. I can't count diagonally, but if I count up and down, 1, 2, 3, 4, 5, aha! then it's easy for me to see there's another point on the outside of the circle. And I can do this way. 1, 2, 3, 4, 5. I can do it this way. 1, 2, 3, 4, 5. And I can do it this way. 1, 2, 3, 4, 5. Perfect. Now I know what you're thinking. Mrs. Dodge, a circle is the collection of all points 5 units away, not just up, down, left, and right. Yes, you are correct. But this at least tells me where I need to connect. So I can draw a decent circle. Semi-decent. Decent-ish. You can tell it's supposed to be a circle, and that's what matters. As long as you have the center in the correct place and all of your, left, right, up, down are 5 units away, I'll give it to you. I'll give it to you. Okay. Woohoo! Awesome. Those are all the required examples. Yeah. And I'll show you why this doesn't have a solution. Because this is the real example 3.0. But remember, this is extra and not required for homework. So you can skip down to the next portion of the video if you don't want to see this problem. But I would stick around because it is very interesting and not super hard. So I would stick around. So in this question, I am told that this is the equation of a circle. Find the center and radius, then graph the circle. Interesting. Okay, so same as last time, but this right here, that does not look like, what is it supposed to be? X minus h squared plus y minus k squared equals r squared. These do not look the same to me at all. So what we're going to have to do is we're going to have to take this one right here, and we're going to have to turn it in to this one right here. Mrs. Dodge, how on earth are we going to do that? Well, we are going to do what's called completing the square. So let me rewrite this down here. X squared plus y squared minus 8x plus 4y minus 16 equals 0. So to complete the square, I hope you remember completing the square from before, or from algebra, excuse me. So remember that if I had something like x squared plus 4x plus 4, this is really the same as x plus 2 squared. And hey, this looks exactly like what I want up here. So if I can take something that looks like this and turn it into that, that's going to give me what I want for my standard equation of the circle. So we are going to do this. We're going to do this process right here, up here. And in order to do that, I need my x's together and I need my y's together. So I'm going to rewrite this equation to be x squared minus 8x plus y squared plus 4y, and actually, I'm going to put the 16 over here. And I think you'll see why in a little bit, so if you're confused, just wait till the end. Okay, so now, let's do some color coding here. I have 8 plus x, and I have y squared plus 4y. So I'm going to use these two pieces to complete the square. Now, remember that when I had my x squared plus 4x plus 4, and that was actually equal to x plus 2 squared, hopefully you remember from algebra that whatever b is, if I take half of that, which is 2 in our case, and I square it, that's how I get the c right here. And you can kind of see that from this example. I have x squared, I have 2 squared, which is 4, and then the x and the 2 make up what's in the middle. So I need to take half. I need to take half of whatever the middle term is, 2, and then I need to square it to get me what goes over here. So I'm going to take half of -8, which is -4, and I'm going to square it. So I'll get x squared minus 8x plus 16. Oops, there you go. You can see all of it now. And remember that when I tack this 16 on, because right, this x squared minus 8, that's the same, but all of a sudden I'm just shoving a 16 in here. Now remember, when you have an equation, equations are like teeter-totters for your balancing. And if you just shove a 16 on one side of the teeter-totter, you're gonna... Now your teeter-totter's unbalanced. So in order to keep it upright, we're gonna need to put a 16 over here as well. 16 on both sides. Put the 16 over here, and put the 16 over here too. Okay. Awesome. Huh. Next, we're gonna do the same thing, but for the y's over here. I'm gonna take half of the 4, which is 2, and I'm gonna square it. Oh hey, hey, that's the example we just did over here. So now I have y squared plus 4y plus this 2 squared right here, which is 4. And remember that I have to, if I add 4 to this side, I have to add 4 to that. Okay, beautiful. And let's not forget, we're going to put that equal to all of this, which is 16 plus 16 plus 4 is 36. So now, this is x minus 4 squared. We know that because of the -4 right there. Plus y plus 2 squared. And all I'm doing is I'm taking these. That's how I'm creating what's in the parentheses right there. Equals, and remember 36 is 6 squared. 6 squared. So now I can see that the center, let's color code it. Now I can see that the center is 4, -2, and the radius is 6. That's supposed to be r equals. Ta-da! That one's a little more complicated. You see why this one is extra, but not so bad. Alright, and now let's graph. X, Y. Let's make it purple, because I like purple. 4. So I'm going to start at the center. 1, 2, 3, 4, -2. Beautiful. And now my radius is 6. So 1, 2, 3, 5, 6. 1, 2, 3. 1, 2, 3, 4, 5, 6. 1, 2, 4, 5. And you can get rid of all of them. Alright, and now, whoops. 6. Got rid of that point over there. And now remember, just connect them as fluidly and beautifully as you can. Ta-da! There you have it. Mwah. Beautiful. Okay. And there you go. Yep. There's your solution. That's all I have for you today. Remember that if you have questions, pop into our Google Meet time, even though they're not required. Pop into that time, and I am sitting there waiting to help you. And if you are unable is what I meant to say, to meet me during that time, just email me. I want to help. I really, really want to help. Okay, your homework. Questions like example 1, questions like example 2, questions like example 3, and then you got your bonus, which is like, this is like example 3.0 that we did at the end there. So yeah, not so bad. And you could see that some of these in the beginning really did not take long at all. The one that took us the most amount of time was the one for the bonus questions, which is why they are bonus. Okay. Lastly, your launch. Happiness is not by chance, but by choice. This was very hard for me growing up, because when I was in high school, I was like, well, it just wasn't a good day. I didn't feel happy today. But if you just sit around waiting to feel happy, you might not. If you just sit around and wait, oh, I hope somebody else makes me happy. I hope that I am happy. If you just sit around and hope, or you wait for somebody else to make you happy, you might not be. And no matter what somebody else does, it can never make you happy. You can choose to feel happy because of what somebody else does for you. When my husband takes out the trash, I feel happy about that because I choose to say, wow, I'm so glad that you took the trash out. That makes me happy. But I choose. It doesn't just make me happy. Because what if I'm upset at my husband and he takes the trash out? And then I'm like, oh, you think taking the trash out, that just doing that is going to make me feel better? So, if taking the trash out meant that I were happy, every time he did it, I would be happy. But that's not the case. It's because I choose to be happy about it. So, that's a little bit complicated, I know. So let's boil it down again. Happiness, you can choose to be happy or you can choose to be unhappy. But please don't sit around and tell yourself, it just wasn't a happy day. I just don't have a happy life. Your life can be what you want it to be. Your day can be what you want it to be. So, choose happiness unless you don't want to. Yeah, just because my husband takes the trash out doesn't mean I have to choose to be happy. If I'm upset with him, I could choose a different emotion. But if you want to be happy, just choose happy. And that's not to say that depression and things don't exist. So I'm not saying that you can just choose to be happy and everything's fine. But in most cases, you can think, I want to be happy. Here's what I need to be happy. Let me make that happen. But yeah, do not think that I'm just trying to slap a band-aid on depression or something. That's not what I'm trying to do. If you do have depression or something, a serious case that makes choosing happy very difficult, please seek help, talk to somebody. Heck, ask me. I can give you a list of counselors and people you can talk to because you should never be alone in that fight. But yes, if you want to be happy, I also want you to be happy. I want you to have the tools that you need to be happy. So, that is my launch for you. Take it with you as you go throughout your day. And yeah, if you ever want to talk more about that, or if any part of that I said was confusing, we can talk again. Because this helped me so much once I learned how to be in control of my own emotions, of I want to feel happy right now, or I want to feel sad right now. Like when something bad happens, I want to feel sad. This helped me get a grasp on my own anxiety a lot. Like, I don't want to feel fearful right now, so I'm not going to. Like, once you can get control over your emotions like that, life gets a lot easier because you feel more in control of your life. So, if you ever want to talk more about this, just let me know. Or if you want more launches like this or something, let me know. Yes, take it with you as you go throughout your day. Have a wonderful rest of your day. Thank you for watching. Bye!